For this video, I want to talk about this concept that I sometimes refer to as the black box. The black box in statistics tends to emerge when people predominantly learn how to use statistical programs rather than understanding the concepts behind what is being done. And I talked about how I think the concept of being intelligent consumer statistics is really the goal that we should be reaching for. Many people, even within the research field, knows that you take your data and you feed it into SPS or R or into, for example, the algorithms that we are going to be studying up on Google Sheets, and whatever magically comes out the other end, whether it's significant or not, whether it crosses the 5% threshold, determines whether or not your data is meaningful. Right? And this is problematic because it often means that we draw the wrong conclusions. Right? So this idea that we just feed our data in, the statistics does something magical, and out comes the answer, leads to all kinds of problems. And I want to talk about some of those problems today, real examples of them. This is probably one of the more famous examples. This occurred This was when Dewey and Truman were in a pitched battle for the presidency of the United States. The Chicago Tribune was desperate to figure out who was going to win so that they could print their newspaper off that evening for the headlines for the next day. The problem was the vote would take too long and they would be too far behind to get the headlines out, so they turned to polls. And a new polling company came around and said, hey, we got this idea that'll dramatically increase the speed at which we can poll the country. Prior to this, they revolved mostly going around to people's door, knocking on, asking who they're going to vote for. Well, this new company was going to use this new technology called the telephone. So they'd call people and ask them how they're going to vote. Unfortunately, it turned out that the telephone was only in a small subset of houses. And if you think about a new technology and who is most likely to adapt a new technology the quickest, who is going to have it in their house, who isn't going to have it in their house, think of age, think of income, think of education, think about where they live. You'll probably see that there is a difference about who has the newest technology first. And chances are they're going to vote different than people who don't have the technology. So by calling and asking who they're going to vote for, they got accurate results. The people they called said they were voting for Dewey. However, the rest of the country voted for Truman. Right? So Truman wound up winning the election. The problem was not the statistical approach that they used, the model. It was the data that they selected was not representative of the population. So they were accurate in answering who people who have telephones in their house were going to vote for. However, they then tried to infer that information to the country as a whole, and that's where it fell apart. Here is a correlation. These two variables move with each other. When A goes up, B goes up. When B goes down, A goes down. Right? As one goes up, the other goes up. As one goes down, the other goes down. This is real data that was collected from the USDA. And whenever we're dealing with real data, this degree of correlation is amazing. And 95% correlation really tells you there's a relationship between this data. My question for you is, what variable is causing the other variable to change? Does measure A change measure B, or does measure B change measure A? Actually, pause the video right here, think about it, and come up with your answer. You may be a little frustrated, and perhaps you're thinking to yourself, I bet it would be easier if I knew what measure A and measure B were. Well, let's take a look. Measure A is the per capita consumption of cheese, while measure B is the number of people who died becoming tangled in their bed sheets. So which is it? Does eating cheese cause one to become tangled in their bed sheets and die? Or perhaps is serving cheese the traditional dish for funerals of people who've been tangled by their bed sheets? Well, at this point, you're probably realizing that there isn't a relationship. That correlations do not equal causation. Just because two variables correlate with each other doesn't mean they cause one another. And this is a huge point that often gets missed when we think about the relationship between data. For example, One of the best predictors of shark attacks is ice cream sales. As ice cream sales go up, shark attacks go up. As ice cream sales go down, shark attacks go down. Why might this be? Is it somehow that eating ice cream causes your blood to become nice and sugary, causing sharks to want to eat you? No. I think if you pause and think about it for a minute, you'll probably come up with some good answers. The most likely is probably the time of year. People are most likely to buy ice cream in the summer. That's when people are most likely to be swimming out in the ocean. That's also when sharks are most likely to be close to land. So here's a strange experiment. A group of researchers went down to the docks and purchased a dead salmon. Fully dead salmon. They took it back to the lab and they stuck it in an MRI machine. And then they showed it pictures. They showed the dead salmon pictures of either human faces or houses. Then they analyzed the fMRI scans, and this is what they discovered. Turns out there was an area in the salmon brain that was different when they were showing it houses versus humans. Yes, they were able to detect a difference in the brain activity of the dead salmon. Is this the case of a zombie salmon apocalypse? No. This was a problem with the analysis of the data. The researchers did this on purpose to highlight the fact that the technique that many people were using to analyze fMRI data at the time had a glitch where it was very easy to get false positives. Right? They weren't properly controlling for the variables, and therefore a lot of the data and a lot of the conclusions they were drawing were invalid, and this was just to really highlight that fact. So these are some examples to show you, right, that being an intelligent consumer of statistics can help you even if you're not doing the analysis. You can look at what other people have done and you can draw conclusions about whether or not their techniques and the inferences and the conclusions they're trying to draw are valid.